So chapter 6.1, functions and systems of equations in two variables. What we're going to do is we're going to evaluate functions of two variables, understand the basic concepts about systems of equations, recognize types of linear systems, apply the method of substitution, apply the method of elimination, apply graphically and numerical methods, and solve problems involving joint variation. So just a really quick review. If I asked you to evaluate given this point and this function, these are two variables. So because you're evaluating, that means you're just substituting in, right? So I'm going to substitute in 2 for x and 3 for y. And that's going to give me 2 times 2 minus 3 times 3, right? And we get 4 minus 9, which equals -5. Simple enough, correct? Yes, whether you agree or not. Same thing here. So I have V standing for volume. The volume given the radius and height of the sphere. So given the radius and height, I have 1/3 pi r squared times the height. And it tells me that 3 is my radius and 2 is my height. So I'm going to plug them in. 1/3 pi times 3 squared times 2. And that's going to give me 3 pi times 2, which equals 6 pi. Okay, and so evaluating, easy peasy. Okay, systems. This should look familiar. So systems is when you're working with two variable equations and you're trying to determine if there's a solution. If there is a solution, that means they meet at an intersection, right? And if they're meeting at the intersection, we have one solution, and we call this consistent and independent. So the system is consistent and independent. If they overlap, coincide is what this is called. If they are coinciding lines, then there are infinitely many systems, and it's consistent and dependent, okay? And then last, systems of equations. Or not systems. Oh, easy. If they are parallel, so if we have parallel, they have 0 solutions and it's inconsistent. The other thing to pay attention to is just by knowing how to do this based on the slope. So when you have different slopes, if the slopes are different, so different slopes, then you know that you're going to have intersecting lines, okay? If you have the same slope, and same y-intercept, then you're going to have coinciding lines. If you have same slope, but different y-intercept, then you're going to have inconsistent, parallel, no solution. So you can tell without even graphing or actually going through and solving what type of solution you're going after. So graphically, how do we do this graphically? Well, graphically, step 1, you set up each equation to be graphed in slope-intercept form. So slope-intercept form is our y equals mx plus b form, right? And then step 2, you graph each equation and look for the intersecting point. Write the ordered pairs as your answer. Check your answer by substituting the point in both equations. So when we're graphing, remember you graph starting with your y-intercept when possible, and then you use your slope as your rise over run. So here we have, we're going to graph each system equation and find any solutions. Identify the system as consistent or inconsistent. If the system is consistent, and we're going to state whether the equations are dependent or independent, okay? So I thought I split this page. Un momento. So first step is you want to get y by itself. So in the first equation, when we get y by itself, now my pen has stopped. What's going on? All right, so we're gonna get y by itself. So this equation is gonna end up becoming y equals x minus 1. And this one's gonna become y equals x minus 1. So what does that tell me about the two? Before I even graph, I know that it's gonna be, they're gonna be the same, right? So they're gonna be dependent. So it's consistent and dependent. Because they're coinciding lines. And because they're coinciding lines, that means when I graph, it's just gonna look like one line. So I come down to -1, go up 1, over 1, up 1, over 1. You get the gist here. And I'm gonna do my very, very best to connect these lines. Oh, that wasn't my very best. Okay, and it's just gonna be one line. So it's consistent and dependent. All right, this one, again, our first thing is to get y by itself. So on the first one, to get y by itself, we end up with y equals 2/3 x minus 1/3. And then on the second one, we're going to end up with y equals -1/2 x plus 2. So on this one, the -1/3 is not going to be that easy or fun to graph, but off the bat, I can determine what they are. So they are consistent. So it's consistent, and it's going to be independent. And that's because I have two different slopes. Do we see that? So I'm consistent and independent. And if I was to graph at -1/3, it would be really hard to graph. So what's another value I can plug in to get something prettier to graph? I plug in 0 for x. No, that's not pretty either. I just need 1 point, and then I can follow the slope from there. What happens if I plug in? I don't know. Why am I having a brain fart? I guess if I plugged in, that would be at 1.5, and that's just not an easy number to graph. So we're gonna do a very careful job. So I'm gonna graph the second one. That's easy enough. So we're gonna go to 2, and from 2, I go down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. And I'm going to connect. Right. Guys, I'm seriously concentrating to make that line. And I think I did a fairly good job. In the beginning, I did. So on here, if we're starting at -1/3, it's going to be really hard to kind of count that, but we can do our best. So -1/3 would be right here, right? And so for -1/3, I'm going to go up 2 and right 3. So I'm going to go up 2. So I'm at +1/3. Then I'm at +1 1/3. And then I'm going to go over 2. Went over 3. 1, 2, 3. About as even as I can get. Yeah. And so I went from here to here, and I'm going to connect them. Oh, I tried my very best. All right, and it appears roughly that my point of intersection is going to be at 1, 1. which is not very accurate. I would do better. But this is just showing you how to graph it, and we roughed it out as to where the intersection is. It's probably a little higher up. Should be like probably.
Is it 2-1?
2? I am at 2. I was like, that doesn't seem right. 2-1. There we go. And so that's graphing. Hopefully this all sounds very familiar from last year. So let's try another one. So this time, when I look at it, I'm going to get y by itself. So we have y equals 3 x minus 4, and we have y equals 3x plus 1. So this time you notice that the slopes are the same. And because the slopes are the same, it's going to be an inconsistent. That means that these two are never going to meet because they're parallel. And so I have one here at 1, and its slope is up 3 over 1, up 3, 1, down 3, 1, down 3. I like making sound effects, helps me stay focused on it. And then the other one is 3x plus minus 4, 3x minus 4. So it's down here, same slope. I'm going up 3, and then over 1, up 3, over 1, up 3, over 1. Hopefully you guys see the gist of it, that these two are parallel, and I have a feeling that, all right. Didn't work that time. But you can see that they're parallel, and this is why they are inconsistent. Okay, how do we feel about graphically? Good. Silence means good. All right. Next, here is just a word problem. So setting it up and then solving it. So we have in 2010, revenue at McDonald's and Burger King totaled $26.4 billion. McDonald's revenue exceeded Burger King's revenue by $21.8 billion. Okay, so write a system equation that gives the individual revenue of each company in billions of dollars. So when we read this, we are gonna have to decide which is X, which is Y. I'm gonna let McDonald's be Y and Burger King be X. And that's because in the end, it tells me McDonald's revenue exceeds Burger King. So then I can set this up as a Y equals. So I know that X plus Y equals 26.4. And then I know that Y equals X plus 21.8. So this would be my system. Okay. When there's a decimal involved, basically for graphing, we would probably just utilize the calculator. And so let me open my calculator. So in the calculator, we would go to Y equals. And we would type in, the first one would be 26.4 minus X. And then the second one would be X plus 21.8. We would go to graph. We don't see them, so we're gonna go to zoom, and we can go to zoom fit and see if the calculator can do some work for us. And it did some work for us. So then I'm gonna go to second, trace, and I'm looking for the intersection. So second trace, intersect. And it's like, is this your first curve? That's my first line. That's my second line. Yes. Where do they become friends? and they become friends at x equals 2.3 and y equals 24.8. So 2.3 and 24, I said 8, 24.1. So we have x equals 2.3 and y equals 24.1. And so therefore $2.3 billion for BK and $24.1 billion for Matt. So this system was consistent and independent. Okay, how do you feel about doing it in the calculator? Easy enough? No questions, comments, or concerns? Cool, cool, cool. All right, substitution. So typically this test is has free response portion of it, where if we're not in class, you're gonna have to submit the work. But you're gonna have to work at least 2-3 problems using substitution and or elimination methods to evaluate. Okay, so substitution. Step 1 is to solve for one variable and at least one equation if necessary. Then we're going to substitute the resulting expression into the other equation. Then we're going to solve that equation to get the value of the first variable. And then we're going to substitute some more into one of the original equations and solve. And then we write the values that we got from steps 3 and 4, and that's our ordered pair. Again, all should sound familiar. And here we go. So, substitution. You want to identify the term that has a coefficient equal to 1. So in this case, it would be the second equation and the x because it has a coefficient equal to 1. Remember, the coefficient is the number in front. Okay, so we determine which one we're going to solve for. So we're going to get x by itself. So in order to get x by itself, we're subtracting 5y. So now we're left with x equals 13 minus 5y. That step is done. Okay, then we're going to take this value and substitute it into this equation. So we have 3 times 13 minus 5y equals, I'm sorry, I didn't mean to write equal, minus minus 2y equals 5. So we substituted it in, and now we're going to solve for that variable. So now we're going to evaluate this for y. Well, not evaluate, solve for y. So I'm going to distribute. And I get 39 minus 15y minus 2y equals 5. Combine like terms. And I have 39 minus 17y equals 5. Combine like terms. Subtract 39. And I get negative 17y equals negative 34. Divide by negative 17. And we get y equals 2. So we have y equals 2. And we're going to take this and plug it back into this to find our x. So x equals 13 minus 5 times 2, which equals 13 minus 10, which equals 3. So x equals 3. So our solution is 3, 2. Ringing bells feels familiar? Yeah. Okay. Silence is golden, I guess. All right, here, so in Algebra 2, you only work with linears. Here, we're also going to work with quadratics. So, again, you're going to identify the equation that has the variable with a coefficient of 1. That would be this guy, okay? So I'm going to solve for y. In order to solve for y, I'm going to subtract 3x squared. So that leads me to y equals 5 minus 3x squared. I'm going to substitute this in for the y here. So we have 5x. So 1, 2. So we have 5x plus 3 times 5 minus x squared equals 1. We're going to distribute, and we get 5x plus 15 minus 3x squared equals 1. Because this is a quadratic, we're going to have to, this is a quadratic. We're going to have to use our techniques for solving quadratics, which means that one side needs to be equal to 0. And so that I can have a positive a, which doesn't really matter. I'm just going to move everything to the right. So I'm going to be left with 0 equals 3x squared minus 5x and minus 14. So when I solve this, I'm going to have to either do the quadratic formula, I'm going to have to quadratic formula, I can do completing the square, I can do grouping. It's whatever you want to do to solve. So what multiplies to give me negative 12 but adds to give me negative 5? So what two numbers multiply to give me negative 12 but add to give me negative 5?
Negative 6 and positive 1.
Negative 6 and positive 1. So we end up with 3x squared minus 6x plus 1x minus 14. So I can't do grouping. It's not going to come out pretty. So that means I have to do quadratic. Womp, womp, womp. So quadratic formula. Here's my A. Here's my B. Here's my C. And hit it. X equals negative B plus or minus the square root of B squared minus 4AC divided by 2A. Divided by 2A. All right. So I set up my quadratic. And now we're going to do the math for the quadratic. Okay, so doing the math for the quadratic, we have a negative times a negative is a positive. So we have 5 plus or minus the square root of 25 plus 168 is 12 times 14. Is it 168? Could be making that up. I feel like it's right.
Yes.
I was like, so keep going. And we have, what does that give us? And we're going to take the square root of that. So the square root of 193 is 13.9. We have 5 plus or minus 13.9 over 6. And that gives us 5 plus 13.9 divided by 6. And so one of our x's is x equals about 3 and 1500ths. And then we have 5 minus 13.9 divided by 6. And that gives us negative 1 and 4800. So because I have two x's, that means I'm going to have how many y's? I'm going to have 2 y's. So step 3 is complete. Step 4 is I take the values that I got and I'm going to substitute back in to step 2. So I'm going to take these values and substitute them in. So I'm taking x equals 3.15, x equals negative 1.48, and I'm substituting them back into this equation to solve for y. So we have y equals 5 minus 3 times 3.15 squared. And we'll have y equals 5 minus 3 times negative 1 48 hundredths squared. Plug that into your handy dandy calculator. And we get about negative 24.88. And then on the next one, we have 5 minus 3 times negative 1.48 squared. And that gives us negative 1.6. Okay, so now we have our y's, we have our x's, so our answers are 3 15/100, comma, negative 24.8. And then, oh, I should have kept my rounding the same. Bad job. So this would be 7/7. My rounding is the same for both. 7/7. And then we have negative 1 48/100 and negative 1 57. And that makes sense because if I have a parabola and the parabola looks like this, when a line goes through it, how many points am I going to hit? My line can potentially hit 2. All right, questions by doing it symbolically. I think this, I don't know. Okay, so here's another one. Find the points where the line y equals negative 3x intersects the circle x squared plus y squared equals 10. So this time we have a circle. That's not bad for a freehand circle. And I have a negative line going through it. And I'm looking for where am I going to hit the circle, okay? So it's already ready for substitution. You have y equals negative 3x. So where y is, we have x squared plus negative 3x squared equals 10. That's the first thing we're going to do. So we have x squared plus 9x squared equals 10. That gives me 10x squared equals 10. That gives me x squared equals 1. And therefore, x equals plus or minus 1. So I found my x's. To find my y's, I'm going to plug in. So I have y equals negative 3 times positive 1. And I'm going to have y equals negative 3 times negative 1. So it's going to go through my circle over here and over here. So my points are 1, comma, negative 3 and negative 1, comma, positive 3. So they're not all substitution are going to be as involved or as long as the previous example, just to show you. Okay. So here we have 2x squared minus 1 equals negative 1, and we have negative x squared plus y equals negative 1. These are just additional examples if we feel like we need to do them. If you are feeling okay about, this is old. Oh yeah, this was an exit ticket. Never mind. I meant to change this. This will be an exit ticket. But we're not doing it, so you can practice it later. All right, elimination. So our last method is elimination. I don't think we're gonna really have time to dive into it. Maybe we can get one example in 5 minutes, so we'll do one example before 4 classes up. So with elimination, you're going to write the system so that like terms are in line. So basically, you're writing your system in standard form, which is our ax plus by equals c. We want to eliminate one of the variables and solve for the other variable. And then we're going to substitute the value of their variable into one of the original equations and solve for other variables. At step 3, you have also the choice to do elimination again. No, we're on the 3rd variable. Sorry. At step 2, I think that's the right one. At step 3, you're able to do elimination again if that's what you choose to do. You do not have to substitute unless you're like, oh, it's easier to substitute. So for example, we have the system, and right off the bat from the system, I can tell that I'm going to eliminate 1. So step 1 is write the system. It's written into line. Step 2 is to decide what are you going to eliminate. Well, I can eliminate 2, right? So the 2's are going to eliminate when I combine. So 2's go away. And I'm left with y equals 2. And then after I solve that, so this is the ending of step 2. Step 3 tells me I'm going to take that value and plug it back into one of the originals. It doesn't matter if you plug it into this one or to this one. It's going to be all the same. So I'm going to do 2x minus 3 times 2 equals negative 2. And this gives me 2x minus 6 equals negative 2. I'm going to add 6. Gives me 2x equals 4. I'm going to divide 2. And I get x equals 2. So now I know my solution is 2, 2. This is considered a basic one because you didn't have to manipulate anything. The elimination happened naturally. And so you have a solution. So this is a consistent, independent function. Consistent, independent system. And that would be it by elimination. So elimination is you're combining, which is addition, the 2 equations together and eliminating because it's going to become equal to 0, and then solving for one variable and then substituting it in to solve for the last variable. Oh, I know what I was mixing it up with 3 variables, which is what we're doing in Algebra 2 right now. So tomorrow we will pick up on elimination and continue and work our way through this week. If you have no questions, then that is all, folks.